As an exercise, just a verbal exercise that I gave for homework in class, I want people to find the vertex for their flow model, the flow model that was derived last week, and tell what the vertex means. That is, tell what the t-coordinate and the y-coordinate of the vertex mean in terms of what's happening in that cylinder as water flows down the cylinder. Okay, now this has nothing to do with this. This is poorly laid out, I apologize for that, but just ignore this. This is a verbal exercise given as an assignment. But if we come down here, we're going to explore how we can use the y equals x squared graph, which is here, to tell how fat or how thin any parabola is by just looking at its formula. Now, if we have the y equals x squared graph, you notice that we have the vertex here at 0, 0. If we move over 1 unit, we're going to move up 1 unit. Move 1 unit to the right, we've got to go 1 unit up to find the graph. If we go 1 unit left of the vertex, again, we've got to go 1 unit up in order to find the graph. Now, we could stretch this y equals x squared function by a factor of 2. We grab it by the y-axis and pull it apart, leaving the t-axis where it is, but pulling every point twice as far from the t-axis. If we do that, then the y-coordinate of every point is going to double. So instead of being 1 unit here, it's going to be 2 units here. At a point where the y-coordinate of the original y equals x squared graph is 2 units high, when we double it, we're going to go 4 units high, which is off the scale of the graph as we see it. Every point on the red graph is going to move twice as far from the y-axis in a vertical direction. We call this a vertical stretch. We're stretching the graph vertically. And when we double all the y-coordinates of y equals x squared, well, the y-coordinates are always going to be twice as big, so we're going to say y is 2x squared. So we've obtained the graph of y equals 2x squared. Now, if we consider the graph of y equals 0.015 t squared minus 2.15 t plus 88.7, we see that we can find the vertex. Remember, we're going to get that out of the quadratic formula. It's going to be negative b over 2a. So we've got a vertex. If we want to then sketch the graph, we've got to know how fat to make it. Well, just as the number in front of x squared over here told us that if we move over 1 unit, we're going to move up 2 units, the number in front of t squared here tells us if we move over 1 unit, we're going to move up 0.015 units. If this number was negative, we would move downward and we would have an inverted parabola with the vertex. So that we now know how to find the vertex and the fatness or spread of the parabola. If we move 1 point right or left, the number in front of the squared term is how far we're going to move up. If it's a negative number, of course, moving up by negative is the same as moving down